Hello friends, I am Chandan. This is the new chapter of thermodynamics, that is second law of thermodynamics. In second law there is a two statement, one is Clausius statement and one is Kelvin Planck statement. But first we will understand what is the primary statement of second law. So in primary statement, the second law says that according to the second law of thermodynamic, thermal energy at high temperature is more significant compared to the same amount of heat at low temperature. Okay, and and work is the best grade form of energy. Hence, second law of thermodynamics is also known as qualitative law. So this is very important. Why second law of thermodynamics is a qualitative law? Because because here work, remember that according to the second law of thermodynamics, thermal energy at high temperature is more significant compared to the same amount of heat at low temperature. Okay, and work is the best grade form of energy. Hence second law of thermodynamics is known as qualitative law. So remember this concept. Now this law, this is the second law which decide direction of the process. So here basically second law indicates the direction of process using the concept of entropy. So here new concept is coming to the picture, that is entropy. So from second law entropy concept is coming. Now hence this law is also known as directional law because it, it decides the direction of the process. Okay, so here more the entropy, less the efficiency. Further, when you study entropy, you can see that if there is a more entropy, that means less efficiency. Okay, you will understand entropy later. Okay, now so what is first law of thermodynamics? So first law of thermodynamics only deals with quantity of the energy, imply that heat at high temperature and the same amount of heat at low temperature have same significance. So remember this data. So here the here the heat at high temperature and the same amount of heat at low temperature have same significance. So the amount of heat at higher temperature and the amount of heat at lower temperature have the same significance. So that is why this law is also known as quantitative law of thermodynamics. So remember that this law is also known as quantitative law of thermodynamics. Okay, so this was the primary statement of second law and first law. Okay, now in next lecture we will understand what is the Kelvin Planck statement, what is the Clausius statement, what is heat engine, what is heat pump, and what is refrigerator. But first we have to understand what is the source. What is the source? SOURCE. So basically it is a thermal reservoir which can provide large amount of thermal energy without undergoing any temperature change. So this is basically source. Source means basically it provides large amount of thermal energy without undergoing its temperature. There is no change in temperature. Example, this is sun. So in sun have you can absorb the heat from the sun. Large amount of heat can be absorbed from the sun and there is no temperature difference. So that is why, that means temperature constant. There is temperature is constant. So this is basically known as source. Okay, now what is sink? Sink is that it is the thermal reservoir which can absorb large amount of thermal energy without undergoing any temperature change. So basically So sink is the reservoir which can absorb the thermal energy without any temperature change. Basically, the example of this sink, that is atmosphere. So atmosphere can receive or absorb the thermal energy without undergoing any temperature change. Then you can say that it is a sink. Source means it provides the large amount of thermal energy without undergoing any temperature change, and sink is the absorb the large amount of thermal energy without undergoing any temperature change. So the example of this sink, that is atmosphere. Now, in second law, we'll understand second law of thermodynamics. That is, there is a two statement, that is Kelvin-Planck statement and Clausius statement. So, in next lecture, we will cover the what is second law of thermodynamics, basically Kelvin-Planck and Clausius statement. So, this is my handwritten notes. You can download it from the description, and there is a Telegram link is there. You can join to get daily update on it. Okay, thank you.